the ideas of passing by reference or passing by value are actually surprisingly closely tied to the ideas of destructive and non-destructive functions. Let me first tie in this idea of a void function. Pass by reference is what makes it possible for us to write void functions that have some side effect. Now, not all void functions need to have some side effect. I need to use this pass by reference. Print is a great example of that. You can give print anything, and it doesn't matter whether you pass in arguments that are passed by reference or passed by value. Print just takes them and writes out to the terminal something like whatever you passed in. But because lists and dictionaries and these mutable types are passed by reference, we can write void functions, which don't return anything, that have a side effect. They mutate the list that's passed in, and they don't need to return any value because they actually update the value that's referenced that you pass in. And this idea of a void function that takes something by reference and mutates it is exactly an example of a destructive function, like what we learned about in the last couple of lectures, because it's mutating the input that it's given. So let's take a look at an example of this idea. So we've seen destructive functions before. You pass in a list, and this list is passed by reference, because in Python, mutable types are passed by reference. Again, meaning that the variable inside of our function is actually a reference to the variable that was passed, to the value that was passed in. And so any changes that happen inside of the function for these mutable types that are passed by reference actually propagate to the value that was passed in. And so here, this is a non-void destructive function because it still returns something. It returns nums. But when we run this function, oops, let's come over here. In fact, I think it's the same function that I have here. Yeah, which we looked at earlier in the lecture. You'll notice that because nums is a reference to the same list numbers, when we return here, when we return nums, this return value, again, is what the function call evaluates to. So add to numbers evaluates to this value, to nums, because that's what we return, and we save that value in result. Notice that result now holds a reference, a pointer, to the same exact list that numbers is. So numbers and result now refer to the same thing. Because the list was passed by reference, and so it was a reference that was passed into our function, and we returned that reference, and so now result points to the same exact thing. And so when we go in lines 7 and 8, print out result and print out numbers, they actually print the exact same thing. Whoops. You can see they print out the exact same thing up here because they actually refer to the same value. And so we're able to write a void destructive function which doesn't return anything because we don't need the return value. Whoever called your function, if they pass in something by reference, meaning they give a mutable argument, so it is passed by reference in Python, then changes that you make inside, like anything that you mutate nums, whenever you mutate nums, your nums actually refers to the exact same thing that was passed in. So whoever called you, wherever that call happened, must already have a reference to the object that's being changed because they passed that reference into the function as an argument. And so that means that if you print out the very original value, the original variable, sorry, we see the change that happened. So when I run this code, all this function does is it mutates nums. Numbers is our actual list, but when we call our function, because lists are passed by reference, nums refers to the same list that was passed in. So we see this 1, 2, 3, 4. The mutation that happens inside of the function, so adding 2, is actually changes the underlying list that was passed in. And so we can just print out numbers and we see that 2 was added. And we didn't need to return anything to see that change. Yes, so this is kind of a general rule and what I was getting at in the destructive versus non-destructive lecture. Destructive functions that modify their input don't have to return something. They can be void functions because whoever called your function already has a pointer or a reference to whatever object is being mutated. There's lots more examples of this. Here's this remove 2. So nums.pop2, I think we'll pop index 2. So we'll get rid of the number 3 here. And result equals remove 2. In fact, let me make this just a little bigger so it doesn't get chopped off here. Just like that. So here, this is a non-void destructive function because it does mutate the input, but it still returns something. But you actually don't need to return anything. You can still access, like, you can see the change that happened to numbers just in the numbers function, in the numbers variable here. When I run this code, you can see that calling remove 2 on numbers, where the function pops index 2, which is the number 3, the original list numbers gets updated. So the list when we print it out after calling the function is 1, 2, 4. In fact, if I had printed it out before calling the function, print numbers, we would see that before it was 1, 2, 3, 4, and afterwards it was 1, 2, 4. Now I'll show 2 more quick examples. The same thing is true for dictionaries. And so maybe you can pause the video and stop and take a look at this function and think about what will the value of result be and what will the value of count be after this function is executed. So our dictionary here starts off with A3, B1, and we call add C on this count. And remember, count is mutable. So take a second and pause the video and think about what will happen. Then I'll explain it. So what happens here is, same thing as with lists. Because this is a mutable data type, when we call the function add C and we pass in this variable that holds a mutable data type, a dictionary, in Python, mutable types are passed by reference. So the thing that's actually passed into the function is a pointer to that same existing dictionary. And so any changes we make, mapping C equals 2, actually updates the dictionary that's referred to. And so both result and count point to the same thing. The original dictionary count has its value updated. So because of that, we actually don't need to return anything. Just by calling add C count, you're mutating count itself because it is the reference to count that's passed, not a copy of count. This is a void destructive function. And one last example here, remove C, same exact thing. Whenever you pass in a mutable type, a dictionary, changes to that value the mapping variable actually refers to the value that exists already because it is a reference that is passed in. And so both result and count point to the same dictionary, and so you'll see both of them become A, B only. They won't have C anymore. So that's why you can change this to be a void destructive function. I just want to now contrast this. I've been showing you lots of pass by reference. This only holds for mutable values, so only for lists and dictionaries from what you know so far. So if you call a function like this, add inventory, stock, shipment, if you're passing in 2 integers, which are mutable, immutable types, integers are immutable, you'll see that, so jeans and jeans shipment, if I run this code, when I pass in jeans and jeans shipment, because these are immutable, we actually pass a copy of the value. And so in the frame for our function, stock becomes a variable that's assigned a value of 56 because that was the value out here of jeans. And shipment becomes a variable that is assigned a value of 30, a new value of 30. It's not a reference to these existing values out here because they can't be mutated, they can't be modified. And so just doing stock equals stock plus shipment doesn't update the value of jeans. Like 56 can't change, it's immutable. And so if I print this out, if we run this here, whoops, there we go. So what can you expect this, what do you expect will be printed when I run print jeans? Take a second. Based on what we've learned, because jeans and jeans shipment is passed by value, changes inside don't affect, like changes to stock and shipment don't actually affect jeans and jeans shipment because they were passed by value. Or another way to think about it is also these integers are just immutable, so they can't change. So when you call, when you print jeans, even though in here we did stock equals stock plus shipment, jeans still has a value of 56, not a value of 86, which is what would be printed if we printed stock. Yeah, so inside of our function here, stock equals stock plus shipment. So stock becomes stock, which was 56 plus 30, 86. And that's why we see 86 printed here on the right. But outside of the function, the original value still holds because the value wasn't mutated. Because it's passed by value and it's immutable. That'll be it for today. On that note, I will see you in class. Bye.